Okay, this is 1.3, making predictions within and outside of a data set. So I know we had done a little bit after this, like we did some in the next lesson, but I'm going to go back because I wanted to do those things separately. So, making predictions within and outside a data set. This is page M1-175, 175. And you will need a graphing calculator, whether that be one that is handheld or if you are needing the one that's on the computer. Um, remember to go into the important files and links and open the link to a calculator. So, making predictions. This is why scientists use linear regression. So, if we were talking about or even analysis. So, percent of total US music sales revenue from streaming. So, if they're trying to figure out how much money are they making off of streaming rather than CDs, CDs have kind of been dying out. Not dying out, but people buy them less and just buy it on their iPhone or buy it on some device. So, this is the trend, and that's what we're probably going to see when we look at this. So, using graphing technology to determine the linear regression equation. So, we're going to use our calculator. Remember, you're going to hit Stat. You want to enter the list, so you want to go to Edit. If there's already something in your list, you need to hit this DEL button to delete, 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 delete. Go over to this other and delete, 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 delete. Now, make sure that if you have list 1, list 2, list 3, if you accidentally hit delete there, it will delete list 1, and in order to fix that, you need to go to Stat, go to Setup Editor, and it should say Setup Editor and hit Done. Now when you go back to your lists, it'll have 1, 2, 3, 4, 5. So again, if you accidentally hit delete, hit Stat, go down to Setup Editor, and then hit enter, and it will reset those for you pretty much. So you want to go to edit. We're going to enter this in the X. So we're going to do year is 2000. So we're going to do 2010, 2011, 2012, 2013, 2014, and 2015. Okay, then this is the Y, so it needs to go in list 2. So we're going to do 7, enter, 9, enter, 15, enter, 21, enter, 27, enter, 34. So remember, these are percentages. So it was 7%, 9%, 15%, 21%, 27%, 34%. So you can definitely see that percentage increasing. We're going to see if it actually has some type of correlation. So then we're going to go Stat again, go over to Calc, go down to number 4. Make sure you use this one and not this one. Do not use that bottom one. Notice that has the A plus BX. That's a different form than we use. We want to always use option 4. Should say list 1, list 2. And keep pressing enter. If you do not have the R value, remember to go second 0 where it says catalog. Go down to diagnostic on. It takes a while. Thankfully it's a D and not an S. And then press enter and you'll say done. It won't actually calculate it, so you have to go hit Stat, Calc, and run the regression again. Okay, so here we go. So our equation would be y equals, it gives you the A value of 5.571. I just want 2 decimal places, so I look at the third decimal. That third decimal of a 1 tells you that the 7 needs to stay the same. So I'm going to put 5.57. It's AX. So the A is right there. So that's where you want to plug it in at. So then you put x plus the b is going to be that part. So you're going to have negative 11193.667. 2 decimal places. That's 7, or even it was a 6 and it just kept going. The 6 makes the 6 round to a 7. So that should be 67. So instead of an add, we'll change that to a subtraction. So 11193.67. Okay, now notice it has a positive R value. I do want to talk about that again to make sure that you remember. So that would be an R value of 0.99, meaning it is strong. It's absolutely strong, and it's positive. So as the year goes up, the percentage is going up, which is what we saw and what we talked about. And that's what we said here. So years increase, the number of streaming increase. Okay, so now interpolation. This is the part where we're going to predict. So using your equation to predict the percent of streaming revenues in 2013. So what that means, we're going to write that down. Use equation to predict. Oh, and this is my notebook, and I just titled this page Predictions of Data Sets. So you're going to use the equation to predict. So if a problem says use equation to predict, take the equation you have and plug in, the mathematical word is substitute, what you know to find what is asked. So if we look at this, so we're going to use 2013. This is what we know. Is 2013 a year or a percent? So did they give us a year or did they give us a percent? Well, they gave us a year, so that's going to be our x value. That's what we know. So in our equation, they gave us an x value, so I'm going to plug it in for x. So we already had, and I'm going to use blue because that's what color I wrote the equation in. So 5.57. I'm going to put parentheses 2013. That's what we were given. That's the x value they just gave us. Minus 11193.67 equals y. We don't know this. That's what we're trying to find. So then, of course, use a calculator. You can use the one on your computer. You can use the one on your phone. You can use the handheld. So 5.57 times 2013 minus 11193.67. So we got 18.74 equals y. So in order to do that, I hit this times, then I did minus that number. If you were using a calculator or a phone, you would have to do that step first because you have to multiply, and then you would subtract whatever you got as that answer. So you would do 5.57 times 2013. You would get an answer, then you would subtract 11193.67 in your calculator, or whichever calculator you're using, and that's the answer you would get. So it's telling us 18.74%. If we look, or this next one, no, the actual value was 21. So it's not exact, but it is pretty close. So hopefully you saw that it's pretty close. So the reason that we do this is if we go back, this is the page M1 168 where they were talking about the frozen yogurt cells. So we said as the temperature went up, the number of customers went up. So if I wanted to predict, if I was the owner and I wanted to predict how much ice cream to make, I could use this graph and say, okay, well, the temperature today is going to be 65, so I can expect about 95 customers. It's not going to be exact, because remember, these were the actual points. They were a little off, but if we make a line that predicts that, that's why we do it. That's why scientists or analysts do this, because we want to know how much should I predict. If I am a producer and I want to know how much I should expect, what percentage of my sales will be streaming rather than CDs, because I don't want to make a ton of CDs if they're not going to actually sell. That's a waste of money. So they use these equations to predict information. So we're going to do the next problem and then we will talk about what it means. So use the equation to predict the percent of streaming revenue in 2040. So we're going to ignore that one. I guess we could do it, but we're going to do this one. So in 2040, so I'm going to go back over here because I don't like flipping back and forth when I'm doing the problem. So we're going to, actually we have the equation, so let's just write it over here where I do have more room. So y equals 5.57 x minus 11193.67. And we're going to use what we know. Again, the 2040 is an x value because it's a year. We will get to where they're not the year. And we're going to plug that in there. So I'm going to use 2040. And that seems like forever away, but it's 20 years, which is forever away. But so we're going to do 5.57 times 2040, and I forgot to write in a different color. I'll just write over it in red so you can see it. 2040. We're going to again type that in our calculator. This time I'll use my phone just so that you get to see it differently. So I'm going to do 5.57 times 2040. And I got 11362.8. Now I need to subtract. So then I'm going to subtract 11193.67. I did something wrong, I think. So then I would do let me try it again. So 5.57 times 2040 minus 11193.67. So 169%. Is that reasonable? Can I have 169% be online? No. So it says, is that reasonable? We would say no, cannot have 169% be online. They could have 100%, but they could not have 169%. So just keep that in mind. Sometimes these predictions will be crazy numbers, but scientists would see that and know, okay, that's not realistic. So we couldn't use that prediction equation. The only thing that I want to write down is we did have extrapolation, and then on the page before we had interpolation. So in wherever you take extra notes, we're going to do interpolation. And that is, oops, of course you can't even see it, is predicting using linear regression when it is within the data. So if you look at our table, you know that it was within that information. The 2013 was inside of that. Extrapolation is the outside of that. And my computer just said that I'm out of storage, so hopefully it doesn't stop me. Extrapolation is predicting using linear regression when it is not within data. So if you think the way I think about your beginning parts of your word, so inter, like interior design, extra is like exterior. So this is inside, so within, and then I would write the word outside. Okay, so that's inter and extrapolation. Remember, just use your data and then you're going to decide if it's reasonable, if it's not reasonable, or how close the equation actually is.